Good evening, everyone. And am I audible?
Good evening, sir. Yes.
Ankit, can you confirm? Am I audible?
Yes, sir. You are audible.
Okay. Very well. Good evening, everyone, and a very warm welcome to the NPTL's first live interactive session for the course Engineering Metrology. The course instructor are Professor J. Ram Kumar and Professor Amandeep Singh, and I am an additional TA Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So in this live interactive session, we will be going to solve some sample problems that will help you to solve your assignments problems. So we will solve some questions, okay, some sample questions. And if you have doubt in between, you can put that in chat box, okay. So if anyone opens the mic, it will become a chaos. So I request each and every one of you to put your queries in the chat box. So I will try to answer them. So let's begin our session. So which of the following is not basic unit of the measurement? So can anybody answer this? Anyone from you? Akhil, Ankit? Okay, so yeah, you are right, Ankit. The correct answer for this question is pressure. So do you know why the pressure is not a basic unit of measurement? Okay, so first we list down what are the basic unit of measurement. So there are total 7 basic unit of measurement. Okay, so first one is the mass that we measure in kg. Second is the time that we measure in second. Third one is distance. We measure it in meter. Fourth one is electric current. That we measure in ampere. Fifth one is mole. Sixth one is illumination or illuminance that we measure in candela, and seventh one is temperature that we measure usually in degree Celsius or Kelvin. So these are the 7 basic unit of measurements because they derive naturally, or we can use it for direct measurement. Okay, so if we come to this question, so what they are asking, which of the following is not a basic unit of measurement? So we can cross check these things in our list. So mole is the basic unit of measurement. Candela, that is luminous, it is also basic unit of measurement. After that, distance in meters, that is also basic unit of measurement. Okay, so the pressure, the correct answer to this question is pressure. Okay, so as we know, pressure is nothing but force per unit area. Okay, force we will measure in mass units, and area we will measure in distance units. So that's why pressure is the correct answer to this question. Okay. So moving back to the next question. The testing flatness or straightness of a surface is possible using. There are 4 options: vernier caliper, micrometer, autocollimeter, or all of this. Can any one of you answer this? Ankit, Vivek, Vijay, Akhil, anyone? Okay, so let's solve this question. So now, are you able to see the question? Okay, let me check this problem. Now, are you able to see? Okay. So the testing flatness or straightness of a surface is possible using vernier caliper, micrometer, autocollimeter, or all of these. Can anybody answer this?
Sir, autocollimeter.
Okay. Please use chat box. Okay, it will be better for me because so many people will be opening their mic, so it will become difficult. So autocollimeter. Why is it so? Anyone knows? Okay. So let's see. Suppose I am having a vernier caliper and micrometer screw gauge. Okay. So vernier caliper, it is the end standard. Okay. And in vernier caliper, suppose this is fixed jaw and this is movable jaw. Okay. So we can hold sample in between these 2 jaws and we can measure the length or diameter. Okay. It doesn't give the information on flatness or straightness. Flatness means how the surface is, whether it is tilted by some angle or not. That information it does not give. Okay. It just gives its length or diameter. Similarly, with the screw gauge, we can hold some circular samples to measure the diameter or we can measure the length. Okay. So definitely vernier caliper will not be answered. So this eliminates the possibility of all of this. And similarly, micrometer also does not tell the flatness, or it does not talk about the flatness of the sample. So definitely it will not be an answer. So only one option is remaining, that is autocollimeter. Okay, so the correct answer to this question is autocollimeter. So we will see a little bit about the autocollimeter. It will help you to understand. Suppose, suppose I am having it works on the principle of light. Okay, so I am having one LED source. Okay, it will emit a light. Okay, and I will be having one beam splitter. Okay, so this is the LED light source. Okay, and here we will be having one sensor which detects the reflected light. Okay, so here I will be having one lens and this is our sample. Okay, so this is our flat sample. Okay, perfectly flat sample. Okay, if this is perfectly flat, then the reflected light will come to at a position to this center. Okay, it will reflect back. Yeah, let me change the color. Okay, it will reflect back. Okay, so blue color reflection of perfectly flat surface. Okay, suppose this surface is tilted by some an angle alpha. Okay, so this will reflect the light at some angle, some different some other angle. Okay, okay, okay. So there is some difference between the perfectly flat spot and the deflected by an angle alpha. So this gap gives the information. So here we will be having some control system that will process these signals, and accordingly we will get a result or measurement on the surface that will give the information about the flatness or straightness of a surface. Okay, so moving to the third question, in a permanent magnet in a permanent magnet moving coil ammeter, the deflection of the moving point is inversely proportional to the current. So can anyone answer this? Okay. Chandu, Umesh, Vivek. Okay. Antanu, Vivek, Manoj, the answer to this question is false. It's not true. Okay. So why it is not true? We will see. Okay. So suppose consider this is the dial of one instrument. Okay. So and here we will be having two magnets, north, south. Okay. This will be the pointer indicating the values, and this is its reference position. And here we will be having one torsion spring. Okay. Okay, permanent magnets. Okay, so when we give current to this ammeter, what will happen? It will deflect with some angle theta. Okay, it will deflect with some angle theta, and that why it is moving, because that applied current will produce some deflecting torque for which will help in deflection of the pointer. Okay, so let's see. Let's assume this is our TD. Okay, so TD is directly proportional to the current. Okay, so TD is equal to G into I. Okay, so here G is the material constant and I is the current. Okay, so as you can see, this G is independent of the flux or applied current. Okay, So now, so if we want to bring this pointer at a stable position, so there should be a counter torque, counter torque should be applied, then only it will come to a stable position. So the counter torque TC equal to counter torque that will be applied using this spring. Okay, so the counter torque will be equal to K into theta because of this much deflection it causes. Okay, so to bring this pointer to a balanced position, these two should be equal. Okay, let me assume this is equation 2 and this is 1. Okay, so 1 should be equal to 2. That is K theta should be equal to G into I. Okay, if we arrange it, I is equal to K by G into theta. So K is the stiffness of the spring or spring constant we can say. Okay, and it is dependent on the material and dimension of the spring, and G is the constant. Okay, so this whole term K by G become constant. So what we can see, I is directly proportional to the deflection. So here what they are saying, in permanent magnet moving coil ammeter, the deflection of the moving point is inversely proportional to the current, which is false. So the correct answer to this question is false. Okay, so moving to our next question. Moving to our next question, that is, blank measures the difference in temperature between two junctions. So can anybody answer this? So we have 4 options: manometer, thermocouple, barometer, infrared thermometer. Thermocouple. So do you know what are the applications of manometer? In which places we use manometer, thermocouple, barometer, infrared thermometer, and why manometer means for which purpose manometer and barometer are used? Yeah, Ankit, Vijay, you are right about the thermocouple, and Akhil, yeah, manometer we use for pressure measurement. Okay, so here we can see that manometer, this is the U-type manometer that I have shown in this figure. So in U-tube manometer we will be having a filled it with the liquid. Okay, initially the height of liquid, okay, will be the same in both the sections. Okay, means if the pressure is same at these 2 points, means 1 and 2, so height of the liquid in this 2 U-tube will be same. Okay, when we increase the pressure from one side, what will happen? It will try to push down the liquid, which will result in the increase in height of the liquid or a rise in the liquid level on the other side. Okay, H, and that will give us the pressure of the measure of the system that we are going to measure. Okay, similarly this is barometer, this is manometer, this is barometer. Okay, so barometer we generally use it for measuring the atmospheric pressure. Okay, if you want to measure the atmospheric pressure at different location, suppose what is the atmospheric pressure at Chennai, what is the atmospheric pressure at in Kanpur, what will be the atmospheric pressure at Siachen. So to measure the atmospheric pressure at different location, we use the barometer. So barometer what happen in barometer, we will be having one reservoir, and that will be filled with the mercury. Okay, and one small glass tube or capillary tube will be inverted inside, will be placed inverted in that the reservoir. Okay, so when the atmosphere apply a pressure on that mercury surface, it will result in increase in height. Okay, or it will result in rise of mercury level inside the tube, which will give us the atmospheric pressure. So here you all can see that this is the infrared thermometer. In COVID, many of you have seen that we measure body temperature using this one. So the correct answer to this one is the thermocouple. Okay. So generally, in general, the thermocouple is a sensor. Okay. That measures temperature difference. It consists of two different types of metal. Okay. Suppose this is metal 1. Okay. And this is metal 2. Both were joined together, okay, at a junction, and another junction will be maintained at a cold temperature. Okay. This is junction 2. Cold temperature, and here we will be heating it. Okay. So heating element, and this means this will create a voltage inside the circuit, and that will be measured using the devices, and that will be proportional to the temperature difference. So this is about the thermocouple. So moving to our next question, the physical variable that are measured between two values, one is higher calibration value H and the other is lower value L. The difference between H and L is called range. So this is true or false? Can anybody answer? So before answering this question, we should know the definition of range. Okay, what do you mean by the range? Okay, so range is the capacity with which the instrument is capable of measuring. Suppose I am having one steel rule. Okay, it can measure from 1 mm to 15 centimeter. Okay, so the minimum value that it can measure is 1 mm, and maximum value that it can measure is 15 centimeter. So this is the lowest value and this is the highest value. So range is equal to H minus L. So yeah, it is true that the difference between highest and lowest value is known as the range. The answer to this question is true. So moving to our next question. Are you able to see the next question? Okay. which of the following statement is true? So can anybody answer? Like, resolution of analog instrument is low, resolution of digital instrument is high, analog instruments are cheap and digital instruments are expensive, or all of these? Can anybody answer? Atannu. Yeah, you are all right. Yeah, the answer is all of these. I hope you have gone through the lectures. Sir has provided one table differentiation between the analog versus digital instrument. Okay, so here you can see that the instrument which gives output that varies continuously as quantity to be measured is known as analogous instrument, and the digital instrument, the instrument which gives output and that varies discrete steps and has finite number of values. Okay, so what, and the accuracy of analog instrument is less. So the next difference, and here you can see the resolution of analog instrument is less. Okay, because it can't. What do you mean by resolution? Resolution is the smallest change in the value of the measured variable to which instrument respond. Means how much minimum value that it can measure. Okay, or distinguish. And similarly, sensitivity. So this is about the resolution. So generally, the digital instrument gives the high resolution, and previously it was considered that the digital instruments are expensive because of the electronics involved. But nowadays, this is not a case. They also they come in the same price range as that of the analog instrument. So the answer to this question will be the all of these. Okay, so I will repeat the resolution. Okay, so what is resolution? The smallest of measured quantity which changes the indication of a measuring instrument. Okay, so it is the smallest change of measured quantity which changes the indication of measuring instrument. Okay, suppose I have one ammeter. Okay, let's consider I have one ammeter. Okay, so when I give input of 1 ampere, so it will deflect. Okay, and or more than 1 ampere it will deflect. But if the input is less than 1 ampere, it will not be able to deflect the pointer. So what we mean by, if the input is 1 ampere or greater than 1 ampere, then only it will detect. So what means, it can measure only minimum. The minimum input needed will be 1 ampere. That will be its resolution. Means only 1 ampere change it can, or more than 1 ampere change it can detect. Okay, less than that it will not detect. So that is the resolution. So coming to the next question. Atannu, I hope you got it. Next one is the, when the distance between two engraved lines is used to measure the length, it is called as end measurement. So before solving this question, we should know what is the line measurement or end measurement. So let's have end measurement. Okay. Okay. So what is end measurement? When the distance between two flat parallel surface is considered as a measure of length. Okay, when the distance between two flat parallel surfaces is considered as a measure of length, then it is known as the end measurement. Okay, so we'll simply explain this with one small example. Suppose I have this box. Okay, I have this hollow rectangular pipe, and I want to measure its internal length. Okay, so what will I do? I will take up blocks of different lengths and I will stack them together and I will measure its length. Okay, LA, LB, LC, LA plus LB plus LC will give its length. Okay, so what is happening if we take one block out? Okay, so this is the flat surface. And these two are the flat surfaces, and we are measuring we are taking these two flat surface for measurement. Okay, this is the solid block. Okay, so that means the end measurement. Okay, and when it comes to the line measurement, that is when distance between two engraved lines is used to measure the length. Okay, so consider I am having one steel rule. Okay, so there are some markings on it. Okay, I am not good with the sketch. Okay, please bear with me. So this is the steel rule that we use day to day, and if I use this steel rule to measure the length of some box. Okay, so this box. Okay, so I am measuring the length of this box. So as you can see, this steel rule is marked with some engraved lines. Okay, here some lines are there and these are matching, and using this line we are measuring its length. Okay, so it's representing the line measurement. So let's come to the question. When the distance between two engraved lines is used to measure the length, what it is called? Line measurement. So answer to this question will be false. So moving to our next question. Which of the following instrument is or are used for end measurement? So can anybody answer this? Anyone? Ankit, Vivek, Vijay, Akhil, Vijay. Tushar, please read the question carefully. Which of the following instrument is or are used for end measurement? Okay. Just now we saw the definition of what is the line measurement and end measurement. Okay, when the distance between two engraved lines is used for measurement, it is known as line measurement. And when the distance between two flat surfaces is considered as a measure of length is known as the end measurement. Okay, so here we have a scale rule, and here we have a inch tape. This is screw gauge. Okay. Let's say I have one block of length L, and when I am using it with the scale, so this we are considering this engraved marking. Okay, suppose this is the 6 centimeters block. Okay, so we are considering the engraved markings on it. So what does it mean? It is the line standard. So definitely scale rule will not be the answer. Okay, so here we can eliminate the second option, that is all of this. As scale rule is not the solution to this question, we can eliminate second option, that is all of this. Okay, now we have two choices, screw gauge and inch tape. Now again apply the definition of end measurement and line measurement to these two devices. Okay, here I am taking that one block. Okay, I am measuring it using the inch tape. Also I am here using the engraved markings. So it is also a line standard. So definitely inch tape will not be the answer. So only one is remaining, that is the screw gauge. Okay, I am holding this inside the in between the fixed jaw in anvil and spindle. So here we can see this is the one flat surface, and this is the another flat surface, and we are using distance between these two flat surfaces as a measure of length. So this satisfies the condition of end measurement. So the correct answer is screw gauge. Okay. So means it is very easy to apply the definition. If you don't know the answer, means if you are not aware of the instrument, and just look at its sketch or its figure and try to apply the basic knowledge, like what is meant by line standard and end standard. Easily you can distinguish which are the line standard, which are the end standard. Like vernier caliper. If you consider the vernier caliper, can anybody tell whether it is the line standard or it is the line measurement or end measurement instrument? Any one of you? Okay, some people saying line, some end. Okay, line measurement. Okay, so in this case, it is the end measurement. Usually, it's the end measurement, not a line measurement. Why? Why is it so? Because if you saw, I think if you have looked at the vernier caliper, okay, let me show you. I will go to previous slide. Okay, here you can see. Are you able to see the figure images? Are you able to see the images? Yeah, now you are able. Okay, so here you can see this. This is the fixed jaw. Okay, this is the movable jaw, and we are holding a sample in between. and we are using these ends for the measurement. So that's why it is the end measurement. It's not line measurement. Okay. Okay. So moving to the next question. What is the resolution of the following data? Can anybody answer this? We already spoke about the resolution. What is the resolution? So you can apply same basic definition here, and you can try to answer this question. Pramod, Akhil, Ankit. Yeah, you are right, Ankit. The resolution is 1. Can you tell why the resolution is 1? Just in one line, can you explain why the resolution is 1? Okay. Yeah, okay, you are right. Here we are having value 23, 24, 25, 26, 27, and 28. So let's consider this is my first output that I got. Okay, the 23. Okay, then I applied some input, some more input, and it showed me 24. Like I applied 23.5. Okay, but it showed me direct value 24. Then I again applied something and I got the value of 25. So what? And here also, Jay, please turn off your mic. You can enter your message in chat box if you have any doubt. Okay, so what I have saw here that the value is increasing by 1 every time. So this is the minimum measurement that an instrument can detect. So that 1 is the answer to this question. Okay. So moving to next question. Which of the following is not a type of drift in metrology? Fiducial drift, zero drift, span drift, combination drift. Can anybody answer this? Okay. Which of the following is not a type of drift in metrology? Fiducial drift, zero drift, span drift, and combination drift. Anyone? It's already given in the lecture. If you have gone through the lecture, then you will be able to answer this question. Anyone? Akhil, Ankit, Vivek, anyone? Okay, so first, before solving this question, we should know what is meant by drift. So drift is the slow change of meteorological characteristics of measuring instrument. So drift is the slow change of meteorological characteristics of a measuring instrument. So suppose I draw plot. So on x-axis we will be having input or measurement, and here on y-axis we will be having the output. Okay. So if we give some input, the instrument will show some output. Okay. So this is the ideal curve that we should get from the instrument. Okay. Suppose I am giving some input. Okay, but means at no input I am getting some output, and the slope of this output curve is same as that of the ideal one. So this drift is known as the zero drift, and in zero drift the slope is almost constant. So when it comes to the second drift, that is span drift. That is when there is no input, there is no output. But as the input, but when what is happening? Are you able to see my slides changing? Can anyone confirm? Okay, so when we provide the input, its calibration changes. Okay, so this is our span rate. Okay, so when there is no input, there is no output. Okay, but when I give some input, its value changes from the calibration. Okay, it doesn't give the accurate value or like that. And third one is the slope is different from that the ideal one. Slope is different. And third one is the combination drift. So combination drift is nothing but the combination of zero plus span drift. That is, its value changes. It will have a zero drift also as well as the span drift. So we have total 3 types of drift: zero drift, span drift, and combination drift. So here in this question, we can see that this zero, span, and combinations are the types of drift. But fiducial is not a type of drift. Fiducial is a type of error. So the correct answer to this question will be fiducial drift. Okay. So moving to our next question. What is the basic unit to measure luminance? So I already shown what are the 7 basics unit of measurement. So can anybody tell the answer to this question? Yeah, Hansraj, Vivek Kumar, you are right. It's candela. Okay. Hey, you are right. I have already shown what are the 7 basic unit of measurement, and you can see that list, and you can simply answer this question. So moving to our next question. One can measure the density of an object by taking its mass and geometrical dimension and applying mathematical expression at the end. This method of measurement is called as exchange method of measurement, direct method of measurement, indirect method of measurement, or none of these. Can anyone tell? And why is it indirect method of measurement? Okay, you are right. But do you know the answer why it is the indirect method of measurement? Yeah, you are right. The answer to this question is indirect method of measurement. So, in direct method, we compare directly with the set standard. Okay, but in indirect method, we use conversion or mathematical expression. So, if you see density, that is mass by volume. Okay, are you able to see what I am writing? Okay, so the mass we measure in kg, volume we measure in distance unit. Okay, so this is derived from our direct measurement. So this is the indirect method of measurement. So moving to the next question. How many translations are involved in ternary measurement? So can any one of you? How many translations involved in tertiary measurement? Most of you are saying 3. Okay, let's see what is the answer. We will solve it together. Okay. So before solving this question, we should know what are the levels of measurement. Okay. Levels of measurement. So there are three levels of measurement. That is primary, secondary, and tertiary. Okay. So in primary level of measurement, so direct observation of the measurement. That is no conversion, or simply we can say no conversion. In direct level of measurement, we directly observe or directly measure the sample or workpiece, whatever you can say, in primary measurement. But in secondary measurement, we measure that quantity with respect to some other. That is, we convert means one conversion into the length standard. Okay, we measure that quantity by converting it into the length. Okay, suppose only one translation. Okay, and for example is pressure. Okay, so pressure we can't see and we can't directly measure. Okay, so in pressure means in primary the thing is that we can observe, okay, that we can see, but pressure that we can't see, we can't measure it directly. So what will happen? Suppose suppose I am having one pressure gauge. Okay, this is pressure gauge. Here some gear is there. Okay, here some rack mechanism, and here I have a spring and rod, and here I am giving the air pressure as the input. Okay, so when I give air pressure, it will translate to upward, okay, and which will result in the rotation of this dial, and it will then only it will give the measurement. So first, that air pressure we are converting into the displacement of that rack, and then we are getting the pressure measured. So that is the secondary measurement. In tertiary measurement, so we do the two translation. Two translation of length. Suppose we are using thermocouple. So that thermocouple will generate the voltage, okay, and that voltage will be measured in terms of length or deflection, and that will go to a brain. So here we are having two levels of measurement. Okay, means two translation. So answer to this question will be 2. So moving to our next question. The instrument in which the measured quantity produces physical effects which deflects or displaces the moving system of the instrument is known as deflection type, non-deflection type, measuring type, none of these. Can anybody answer this? Can anyone? Okay. So as you have seen in the lectures that if we give input, okay, and it gives deflection as output, okay, so that instrument is known as the deflection type of instrument. Okay, so in measuring tape, what we do, we take and we put it on the sample where we want to measure, and it will give us its dimension. So there is no deflection is taking place. So definitely measuring tape cannot be the answer, and none of this will be. Only the answer is deflection type. So moving to DC potentiometer, question 5. DC potentiometer is a deflection type instrument. It is true or false? Can anybody answer this? Anyone? Okay, so DC potentiometer, what it does, it compares known voltage with the it compares unknown voltage. Sorry for the mistake. The DC potentiometer, it compares the unknown voltage with the known voltage. So it will be a null type instrument. Means when unknown value will be equal to the known value, it will show null position. So answer to this question is a false. Okay. So that's it for today, guys. So we will end our session here, and we will meet in next. We will meet next Tuesday. So what we will be doing? We will be solving the similar question to that of the your assignment. Okay, like these are the some similar questions that two of the week 1 assignment. Okay, so in week 2 what we will be going to do, we will be solving the questions that were similar to your week 2 assignments. Okay, so please go through the lectures carefully. So if you attend lecture carefully, so you can see so most of the questions will be answered there by itself. And that's it for today. So if you have any doubt and queries, then you can type in that in chat box. Yeah, wait a minute. Yeah, Hansraj, yeah, you will be getting the recording of this. Yeah, NPTEL team will provide you the recording of this, don't worry. So you will be getting the recording. Yeah, that's for it. That's for today. So thank you for coming here and attending my lecture, our discussion session, and I hope to see you next time in large number. Yeah. Sorry from my side if I am not able to anything clearly because I am just learning also. Yeah.